This is 6-3 conditions for parallelograms. So in order to be a parallelogram, when you look at a figure, you have to be able to prove one of these conditions. So the first one says both pairs of opposite sides are parallel. The next one is one pair of opposite sides are parallel and congruent. For that one, it has to be the same pair of opposite sides, being both parallel and congruent. The third theorem states both pairs of opposite sides are congruent. The fourth one, both pairs of opposite angles are congruent. So for those that you are going to need 4 sides being congruent, and on the bottom you'll need 4 total angles given to you. 4 sides given to you, 4 angles given to you. For the fifth one angle is supplementary to both of its consecutive angles. So that's where you're given that one angle. We'll call this 70. Then we'd have to know that these are both 110. So for that one, you're given 3 angle measurements. 3 angles. And then the last one, the diagonals bisect each other. So you'd have to know that the diagonals are bisecting each other. They'd have to be given both diagonal lengths or have the congruent marks on there. So we're going to look at some so it'll make a little bit more sense. But the reason why we're doing this, I just want to really clarify here. This is kind of the big picture. We are learning about quadrilaterals. The kind of quadrilateral that we are focusing on right now. Oops. So the first quadrilateral that we're focusing on is parallelograms. But there are specific kinds of parallelograms. There's special parallelograms like squares, rhombuses, rhombi, just write rhombus, and rectangles. Okay, so there's 3 types of parallelograms. But then there's other quadrilaterals we're going to learn about as well, such as number 2 would be trapezoid. It's a quadrilateral. And the third one that we're going to learn about is a kite. But the main thing that we're focusing on right now, of course, are parallelograms, since we're talking about conditions for parallelograms. And we have to do this because eventually, if we're going to prove that something is a square, we have to first say that it's a parallelogram, to then say it's a square. If we're going to show that something's a rhombus, we're going to first say it's a parallelogram, then we can say it's a rhombus. And same thing with rectangles. We have to first prove that they're a parallelogram. So everything goes back to a parallelogram. So we have to meet these conditions for parallelograms to show that these other special parallelograms even exist. This will all make sense with some examples. So let's try some. So here they're asking us to show that ABCD is a parallelogram. So I'm going to need a condition from that list of conditions for parallelograms. But first, I'm going to plug in my x equals 7. So for BC, that's going to become 21 when you plug in 7. And for AD, plug in 7. 3 times 7 is 21. And then I'm going to plug in my y. So on the left for BA, that's going to be 20 minus 4, which is 16. And then we'll do the same thing for CD, and we get 16 when we plug in 4. And so I've proven that the opposite sides are congruent. But if I pull up that conditions for parallelogram list again, and I look for something about sides, I've got a few options here that talk about sides. Here, here, here. So I'm looking for it to be one of those, and I see that the third one says both pairs of opposite sides are congruent. So I've met a condition for a parallelogram, so this is a parallelogram. Keep in mind, these conditions for parallelograms are going to be listed on the test for you. These are theorems, and all the theorems for Chapter 6 will be shared for you, for both the quiz and the test. Okay, here's another example. So again, I'm going to plug in my 11 and my 4.5, and let me get the measurements for those. So once I plugged in those numbers, I got 118, 62, and 118. I was only given 3 angles here, so I can't look at, let me look at my options. I'll change the color here. So I've got angles and angles. So it has to meet one of these requirements that's talking about angles, one of these conditions. So I have both pairs of opposite angles congruent. That would mean that I have all my angles, and I don't have that. So I cannot choose 6-3-3. It's theorem. But for the one that says one angle is supplementary to both of its consecutive angles. So this 62 is supplementary to both of its consecutive angles, and so that's why it meets condition, the 5th condition here, 6-3-4. So this is definitely a parallelogram. So here we have 2 quadrilaterals that we're trying to see if they are a parallelogram. So it says determine if they're parallelograms. So it's going to be a yes or no, and then justify your answer. I can justify with one of the conditions. So let's see, I'm looking at example A here. I've got 1 pair of congruent sides and 1 pair of parallel sides. So something about congruent and parallel. And I do see that it says 1 pair of opposite sides are parallel and congruent, but it's not the same side. This has to be the same side. So it is trying to meet this condition, but it's not. So therefore this is a no. It has to be the same side being both congruent and parallel. If I could move those congruent marks to be on the same side that's parallel, then this would be a yes. Okay, looking at example B now. Example B is related to the diagonals. So I'm going to go down and I'm going to find something about diagonals. It looks like this last condition. The diagonals have to bisect each other. So let me double check. Well, the diagonals are making 2 congruent marks. So therefore, since it's splitting them into equal parts, congruent parts, then the diagonals do bisect each other. So this is a yes, and I would write this condition. These are the same type of problem, but a little bit more challenging. So I wanted to talk about this. So first of all, in 2A, I know that I have third angles theorem, so I'm going to put that in. Okay, and if you gave these numbers, it would make more sense, but this ends up making this larger angle equal to each other. Because if you think about it, I'll just make up random numbers here. If the 2 arc mark is, thinner pen, if the 2 arc mark one is 30 degrees, and the blue one is 20 degrees, for instance. And I do the same thing on the other side. This is 20 and this is 30. Our angle addition postulate would say that each of these larger angles that I circled are 50 degrees. So let me delete everything I've done so far here. So I'm saying that because of the third angle theorem, these 2 added together are going to equal the same as those 2 added together. Let me make them double arc marks. Okay? And so now I know that I have met a condition. I have both pairs of opposite angles being congruent. So that one took a lot more thinking. We needed prior knowledge to do that as well. In 2B, it's definitely something about sides. So my options again are all of these things. And it's only talking about sides being congruent, so then I'm definitely into this theorem right here. Both pairs of opposite sides are congruent. This is not true because these aren't opposite sides being congruent. Those would have to be congruent to each other. So this is not a parallelogram. And I would say so because I don't have both pairs of opposite sides being congruent. This is the last type of question you'll see from 6-3. So this is asking us to show that a quadrilateral is actually a parallelogram. And it gives a bunch of ordered pairs by the definition of parallelogram. And you can do this different ways, but the easiest one to do is to show that first condition that opposite sides are parallel. And we can, sorry, that's really messy. Opposite sides are, there's the abbreviation for parallel. And so I can do this. If I drew out a parallelogram being A, B, C, D, then my opposite sides would be AB and DC. If I want to show that they're parallel, then I can find the slope of AB using my formula y2 minus y1 over x2 minus x1. For this slope, I'm going to just write that it's AB so I know what I'm doing. The slope for AB is 7 minus 2 is 5 over negative 2 minus negative 3, which is really negative 2 plus 3 is 1. And so the slope of that one's 5. And this is algebra review, so I don't want to spend too much time on this. Do the same thing for CD. I get negative 1 minus 4, which is negative 5, and 1 minus 2, which is negative 1, and so that equals positive 5 as well. So I know that since they're the same slope, that these lines, oops, I have the wrong symbol, are parallel to each other. And then I would do the same thing for AD and BC. I want to make sure that those sides are parallel to each other as well. So look at AD and BC, and they actually do come out parallel, so this is a parallelogram. There's another way to do this. If this algebra is too complicated for you, you can graph it. Let's just pretend I graphed that real quick for you. Here is the graph of this situation, this problem. And I can very quickly find the rise over run when it's graphed. So if you're good at graphing, I would definitely say this is the easiest way because the slope is 1, 2, 3, 4, 5 over 1. So this slope is 5. I can label that. I do this slope is 5. And I didn't find the BC and AD, but I can tell you what the slope is right now, a lot faster than calculating algebraically. So for B, I'm going down 1, 2, 3 over 1, 2, 3, 4. Let's check that they're the same. So for A to D, 1, 2, 3 down and over 1, 2, 3, 4. So the slopes of those are both negative 3/4 for both, and so that's why I can say that's parallel to that, this is parallel to that, and therefore this is a parallelogram. Here's one for you to try. I've provided a graph for you as well, and I'm going to tell you the answer right now. This is a parallelogram. So GF has the same slope as HJ, and GH has the same slope of FJ. But I just want to make sure you can get that answer. So go ahead and try it. You can solve it both algebraically and with rise over run if you want, or pick and choose which one. But you should get that this is a parallelogram.